Hi everyone, welcome to this episode of Keipert Labs. In today's video we're going to discuss through the concept of acceleration. We've been looking at, so far in our course we've been looking at concepts like distance, speed and velocity, and we've looked at time. These three things being things that we can measure in units like meters, meters per second, seconds, or maybe we're looking at kilometers, hours, and kilometers per hour. So they're all things that we can use, properties that we can use to describe or define an object's motion. Okay, so they all give us information on how an object is moving. But what we know is that the motion of objects that we encounter in everyday life is a little bit more complicated. We use those terms and they help us to understand it, but we don't always deal with things that are always going at the same speed. Okay, that sometimes that we get objects that we would say that are accelerating. So we would say that acceleration is defined as a change in an object's velocity over time. Okay, so we would say, let's say that, let's kind of see if we can elaborate on that with an example to kind of give you a feel for it. Okay, and then we'll talk about the units that we measure acceleration in. So say we've got a car that at a time of 0 seconds is going 0 kilometers per hour. But let's say after 10 seconds it's going 100 kilometers per hour. Okay, so in a time period of 10 seconds, that its velocity has changed from 0 kilometers an hour to 100 kilometers an hour. Actually, maybe what we can do, we'll change this a little bit. Let's talk about this in meters per second. Okay, so let's say that as we go, at 0 seconds we're traveling at 0 meters per second. At 10 seconds we have increased to 40 meters per second. So that is, our velocity has increased. That is, we are going faster than we were at initial time. And so the change in velocity is 40 meters per second minus 0 meters per second. That is to say 40 meters per second. Okay, so that's how much that our velocity has changed by over time. And the time that it was 10 seconds. So what we do is that in order to actually calculate an object, we can actually work out how much it's accelerated by. So what we do is that we say, all right, well, so the acceleration is the change in the velocity over the time in which that change was happening in 10 seconds. Now all of a sudden you may be able to see at this point that our units is going to start to get a little bit weird. Okay, because we've got 40 meters over seconds, meters per second up here, divided by a value in seconds again. And so what we actually say is that we have a value of 40 divided by 10 meters per second per second. And so, but you can see that the slashes going on here starts to get a little bit complicated. So what we actually do is that we say that we call that meters per second squared. Okay? Or, just to kind of get you familiar, we would ms to the minus 2. So what we have in this situation, we've accelerated by 4 meters per second for every second it was accelerating. Okay? So what we would say, so then I'll just, let's kind of rearrange this bubble to reflect kind of the maths of what we just did there. Okay, so the acceleration is equal to the change in velocity over time. Okay, meters per second, that's in seconds. So now we're talking about acceleration in meters per second squared. Okay? Now, being able to work with this formula is not something that's absolutely mandatory in what we're studying at the moment. Okay, it's something that I would expect that you'd be able to do if you're a bit more mathematically confident. The maths here is not overly, like ridiculously hard, but it's also not, a fundamental skill that everyone must be able to do. But especially if you're interested in what we're studying at the moment and you're thinking seriously about physics next year, then I would be expecting you to have a go at doing these sorts of things, to dig a little deeper. Okay, and so what we can do is that we can actually simplify this formula, and we say A equals V minus U over T. Okay, now I understand that looks a little bit strange. So here A stands for acceleration. Okay, so it's the thing that we're trying to find out. U is our initial velocity, and V stands for our final velocity. And then T is our time. Okay, so we can work with this formula and substitute in numbers that we know to help find out the acceleration, or to find out, if it's been accelerating for this, at this much for this length of time, what's its final speed going to be, and so on. So that is, we can find out which one of these four things that we don't know by substituting in the other three. Okay, so without you realizing that this was actually the formula that I kind of used in the calculation before. I said, our final velocity was 40 meters per second. Our initial velocity was 0 meters per second because we started at, without moving, and the time that we were accelerating was 10 seconds. And so then we can substitute in, and we found out our value of 4. Okay, but so the idea is that acceleration is purely about a change in velocity over time. Now, what I want you to keep in mind is that you may have seen this word before, and you may even hear people use it in scientific conversations. What I want you to do is forget this word, deceleration. It's not a helpful word. Because what we can say is that acceleration can be positive, speeding up, or acceleration can be negative, that is, which is what we would talk about as slowing down. So where we're speeding up and slowing down, that in each case that we've got acceleration happening. We have a change in velocity happening over some time period. But that number is positive if we're speeding up, or it's negative if we're slowing down. Okay, so if we're starting off at 10 meters per second, and then we're coming to a stop, then we have over a certain amount of time, then we've got negative acceleration. We're slowing down. Okay, it just helps to kind of keep things clear for us. In light of what we've looked at when we were looking at with speed and velocity, this idea of giving things a plus or minus to talk about direction, it helps to kind of be consistent with that sort of philosophy. Okay, so that this is the sort of thing that we're going to stick with. We're not going to use the term deceleration. We will talk about speeding up or slowing down. We will talk about positive or negative acceleration. Okay, that's the sort of mindset, the sort of terminology we're going to be using. Okay, thanks very much for watching. Bye for now.